Different types of triangles and how to identify them by their sides and angles. So we're looking at classifying triangles. When you have three acute angles, we call this an acute triangle. Let's see if I can get this to focus a little better for you. There we go. Okay, remember acute angles are angles that are less than 90 degrees, right? Acute things are small. So this is an acute angle. When you have a triangle that has three acute angles, we call it an acute triangle, right? When you have one obtuse angle, remember obtuse angles are angles that are greater than 90, but they're less than that 180. Okay, those are obtuse angles. So when we have a triangle that has one obtuse angle, we call it an obtuse triangle. Just draw the triangle notation. When you have a right angle, which is that perfect 90-degree angle indicated by that box in the middle, that square, saying it's a right angle, then when we have the one right angle, we call it a right triangle. When we have three congruent angles, we call this an equiangular triangle. If it was equal sides, we would say equilateral. Okay. All right, so we're going to look at the diagram on the right, and we're going to classify each triangle by its angles. Okay, I'm going to do some color coding here to help me. Just kind of make these pop. Triangle CDE. C to D to E, I'm going to trace it like a little map here, would be this entire angle triangle right here. And as you see inside of that triangle is that right angle. So this is a right triangle. Okay. Next, we have triangle BCE. Just like our angles, I'm going to use that to trace here. So I see B over to C down to E would be this triangle here in the center. And I don't see any notations for right angle, but I do see this obtuse angle. So that means this is an obtuse triangle. Okay, next, ABE. Okay, again, I'm going to use my name of my triangle to help me trace the map here. A to B down to E would be this triangle right here. And I can see by the notations, all of the angles are congruent. Therefore, this is an equiangular triangle. Okay. Next, a triangle BDE. B down to E, B down to D over to E. So that's going to be B, D over to E, and to close that in to make the triangle, I'd come back up. So looking at that bright orange there, looking at the measurements, I see right there, those three angles together are more than 90, making this an obtuse triangle. All right, last but not least here, let me get a little darker color because I'm probably going to have to go over. All right, triangle CFE, C down to F over to E. Kind of hard to see. I'm going to go ahead and shade it in. So I'll kind of pop there. Looking at their angles, if you notice that right angle went all the way down for that, telling me that that angle right there, E, is 90 degrees, so it's not quite all of that. Acute, acute, acute. This is an acute triangle. Okay, so first classifying triangles by their angles. They're either acute, obtuse, right, and if all three angles are congruent, then they are equiangular. So now let's classify triangles by their sides. This is when we get into their fancy names. Okay. So when we have three congruent sides of a triangle, and they'll be marked with our congruency tick marks, just like our angles had our congruency tick marks. All three sides are the same. This is called a equilateral triangle. Okay. Two congruent sides, only two of the sides are congruent. That is an isosceles triangle. And how I remember this is you have two eyes that are the same. It has two legs that are the same. And something special happens in isosceles triangles where if the two legs are the same, then the two base angles are also congruent. So isosceles, you have two eyes that are the same. It has two legs that are the same, or two angles. And last, if we have a triangle that has no congruent sides, and the marks could be like 1, 2, 3, telling you all three sides do not have the same measurement, is called a scalene triangle. So we can actually combine the names here and be a little more specific. Like we could say this is an obtuse scalene triangle. This is an equiangular equilateral triangle. Our isosceles, if that was a right angle, we could even call it a right isosceles angle. So you're going to use both the classification by angles and by sides when we start giving them their full names. All right, so let's practice some here. Okay, triangle by its sides, JKM, J up to K, all the way over here to M. Okay, so I see this one has one mark, but that would be congruent to this one. But we don't have any other measurements, so this is a scalene triangle. Okay, next, KLM. I knew I read that wrong. KLN, right? M made a straight line. KLN, closing that up here. And what I see by their notations are I have two sides that are the same. Just fun fact, that means these two little angles are also congruent. This is an isosceles triangle. Two legs that are the same. We have two eyes that are the same. Isosceles triangle. Okay. Triangle JKN. J up to K, down to N. J up to K, down to N. It's this triangle right here, this pink triangle, and you'll see by its notations that all three sides are the same, making it an equilateral triangle. Fun fact, also means, since I have these congruency marks, I'm going to give these two, that these three angles are all congruent. And throw in there, since we know that a triangle adds up to 180, and when I divide that by 3, each angle is actually 60 degrees. Okay. So it says classify each triangle by its angles and its sides. So we're going to practice. Pause the video, try it yourself, and then come back and see how you did. Okay, so looking at this triangle here, we have one right angle and two sides that are the same, making this a right isosceles triangle. Number 10, I have no legs are marked congruent, and I have one obtuse angle, making this an obtuse scalene triangle. Don't forget to put checks if you got it right, and if you got it wrong, just fix it. It's just some practice here. Okay, let's see how you did on number 11. I can see that all the sides are marked congruent at 7 centimeters, and all of my angles are marked congruent at 60 degrees, making this an equilateral, equiangular triangle. Okay, let's see how you did on number 12. All right, I see an acute, an acute, an acute, 15, 20, 18. So it's an acute by all acute angles, and none of the sides are the same, meaning scalene. So it's an acute scalene triangle. Okay. Next one, I have a right angle, so I'll go ahead and get that written down. So it's a right triangle, and none of my sides are marked or labeled with the same measurement, so this is a right scalene triangle. Again, put checks if you got it right, fix it if you got it wrong. Okay, 97 degrees, that is an obtuse angle, more than 90, and it has two legs of the triangle that are marked the same, so this is an obtuse isosceles triangle. Obtuse isosceles triangle. Okay, let's look at how we can solve for sides of a triangle based off of the algebraic expressions given to us and the identification of the triangle. So on this handout, number 1, we see our algebra here. It says if triangle ABC is an equilateral triangle, I'm going to go ahead and put my congruency marks because I know that that means all three sides are equal to each other. Solve for both x and y. Well, really, it's kind of your choice on which one you want to find first, x or y. We do know that we don't want to put x and y together in the same equation because then it will be a literal equation. There will be too many variables. But what we can do is set either one of these equal to the 49 and solve. And it doesn't matter which one you start with because we have to solve for both anyways. So I'm going to first set it up for my y. I know that is also congruent to 49. And then I will set up my x and make that equal 49. Now it's solving with algebra. So I would add 41 to both sides. Divide both sides by 18, and I get 5 for y. Okay, same thing. Always move that loner constant first. We'll always want x by itself. And then 3 and x are next to each other, meaning they're being multiplied. And so the opposite would be to divide both sides by 3. And we get 16. Okay. So I am going to leave 2 and 3 blank for you to try those on your own. Remember, you can set any of them equal to each other if they're equilateral triangles. All right, so let's scooch down here to number 4, which is an isosceles triangle. And they do have to tell us which sides are congruent. Remember, we don't assume. Obviously, we're like, looks like these two legs should be, but always look for the notation to tell us. These two are congruent. I'm going to go ahead and mark those so I don't forget that. So that means that these two are the only ones I can put equal to each other. That's the definition of an isosceles triangle. two congruent sides and angles. I'm going to throw in angles because that will come in later. Okay, so here we go. 8x minus 13 equals 5x plus 17. Now I'm solving with variables on both sides. It really doesn't matter how you rearrange, but I always tell my students that if you don't know which way to go, just always move all your x's to the left and your constants to the right. So I'm going to move this 5x by changing the sign, so that will cancel. Move my 13 to the right by changing the sign, so these will cancel. And now I have 3x equals 30. Divide both sides by 3. And now I know x is 10. And better go back and read the instructions, make sure I've answered it. It said find x and the measure of each side. Okay, so I'm just going to go back in and plug in for segment DE. It's going to be 8 times 10 minus 13. For segment FE, it's going to be 5 times 10 plus 17. And DF, segment DF, is going to be 10 plus 20. So I just, oops, you can't see that. I just substituted for my x over here. Okay, and so what I get here, 80 minus 13 is 67. No degrees. I know we've been doing a lot with angles, but no degrees. This is a segment, so it's length. 50 plus 17 is 67, which that checks, right? Because it's an isosceles triangle, so two of my legs should have been the same. And then 10 plus, oops, I wrote it wrong, 21 is 31. Right, try the last one on your own and then we'll go over them in class.